Okay, so for this lesson, our objective is to identify a shift of a function to the left or the right or up or down given the function transformation. So we're going to start out with looking at the graph of y equals 2x plus 0. We could also write this as just y equals 2x, or you could say f of x is equal to 2x. So we're going to go ahead and graph that first on our graph. So we know that the y-intercept is 0. So 0 on our y-axis is where we're going to start. And then we also know that our slope here, we have a slope of up 2 and over 1. So we're going to rise 2 spaces and go over 1 space. So it would be up 1, 2, and over 1 space. So this would be our next point. And then again, up 2 over 1. And we could also go in the reverse direction. So keeping on this line, the trajectory of this line, it would be down 2 and backwards 1. So this point here. And then the same for this point here. So we have 5 points total on our line that we can use here. Okay, so this is the line of y equals 2x, or f of x is equal to 2x. Now we're going to move on to the next part. So this says move every point, so every point on our graph, we're going to move this 4 units to the right. So we know that we're moving in this direction. That is the direction to the right. So at every point, I'm going to count 4 spaces to the right. And I'm going to draw this new line in blue. So we're going to count 1, 2, 3, 4 and put our new point here. For the next point, 1, 2, 3, and 4 and put our point here. 1, 2, 3, and 4. 1, 2, 3, and 4. And for our last point, 1, 2, 3, and 4. So here we have a line that has been shifted over 4 units from those original 5 points. Okay, now what is the slope-intercept form of this equation? Well, what we're going to need is we need the y-intercept. Previously, it was 0. But for this one, we're going to need to continue this line so that it hits the y-axis here. So we're going to have to continue moving our points down 2 and over 1, down 2 and over 1. And this is going to give us the y-intercept for this graph. Okay, so where is that y-intercept? Well, we just have to count. This is -2, -4, -6, and -8. All right, so what is the slope-intercept form of this equation? Well, the slope-intercept form is y is equal to, the slope has not changed. We are still going up 2 and over 1 every time. So our slope is still 2x, but here our y-intercept is at a different number. Our y-intercept is at -8. Okay, so we have 2 lines. They both have the same slope, so they are parallel to each other. But the y-intercept is different for each of these lines. So our next thing that we are asked to do is we are asked to factor out the common factor here. So y equals 2x minus 8. Well, I know that a 2 will go into 2x, and a 2 will also go into -8. And we can break this down. This is an additional step for us. All right, 2 times 1 times x minus 8 can be broken down as 2 times 4. And so What we notice here is we have a common factor, and our common factor for both of these is 2. And so what we are allowed to do is to factor out this common factor. So we're allowed to factor out this 2, and then we are left with a 1x minus 4. So 1x minus 4 is what is left for this factored out version of the slope-intercept form. Okay, so let's move on up. Let's answer our next question. Where did the point 0, 0 move to, or where did it translate to? So here's our point 0, 0, and it moved over here to this point. Well, what is that point? Well, that point is at 1, 2, 3, 4, comma, 0. So this point is at 4, comma, 0. 4 on the x and 0 on the y. All right, so in our factored form, where is this translation or this move? So what this is asking us is, in our factored form, y equals 2 parentheses x minus 4, where is our move of 4 spaces? Because at the very beginning, we were asked to move 4 units to the right. And it appears that in our factored form, we have a 4 right here. So our slope was 2, and our move was 4. So we have the 4 is what appears to have the move or the translation.